The German facility is fully booked. Bugatti says 4 weeks minimum. I have 14 hours. We can't wait. Get the team on it now.
300 mechanics, 12 countries, $200,000 to whoever fixed it first. Every single one of them said the same thing. Without the proprietary chassis separation rig, the car could not be touched.
You don't need the proprietary rig. You need what the rig does.
Who are you?
Tom, I'm here with a fabrication quote, but I can have this fixed before your 300 mechanics land.
Catherine looked at the man with the clipboard, then at the 14-hour deadline on her office wall, then back at him.
Prove it. You have 1 hour.
He needed 40 minutes. Drop your city in the comments right now. And subscribe. We put a new story out every single week. Hit that button. To understand how a fabrication shop owner from Newark solved what 300 specialists from 12 countries could not, you have to go back 12 years. To an aircraft component design lab in Michigan. And to one principle that changed the way Tom Reed looked at every problem he ever touched. Tom Reed woke at 5:30 without an alarm. Coffee first. Then, Mia's oatmeal on the low flame. Vitamins on the saucer. Orange juice in the short glass, a preference she had held since age 6, with the specific conviction of someone who had considered the alternatives and found them wanting. 2 knocks on her door at 6:15. Mia appeared in 10 seconds. She had her mother's eyes and her father's habit of arriving exactly when she said she would. She came to the table with her notebook, observations, questions, things worth recording, and looked at him across the oatmeal. Mia. Deliveries today? Tom. 1 fabrication quote. Prestige Automotive Place on Commerce Drive. Mia. The Bugatti one? Tom. They have several cars. I don't know which ones. Mia. I hope it's a Bugatti. Tom. Why specifically? She thought about it. Mia. Because you'd know what to do with it. He looked at her. Tom. I've never worked on a Bugatti. Mia. That's not what I mean. He drove her to school at 7:20. On the way she asked the question she had been holding since breakfast. He could always tell when she was holding one, because she looked out the window for longer than the scenery required. Mia, Dad. When something is impossible, really impossible, not just difficult, what do you do? Tom, I ask what makes it impossible. Mia. And then? Tom, and then I ask whether what makes it impossible can be worked around. Mia, can it always be worked around? Tom, not always. But more often than people think. Most things that look impossible are really just constrained. And constraints have solutions if you're willing to look for them in the right place. She wrote something in her notebook. He dropped her at school and drove back to the shop. Reed Fabrication on Miller Road had been open for 4 years. 3 bays. A CNC mill. 2 welding stations. A hydraulic press. The specific equipment of a shop that worked with metal at the level where precision mattered. Custom brackets. Structural components. One-off fabrications for clients who needed something built to a specification that off-the-shelf parts could not meet. The work was honest and specific, and required a level of engineering understanding that most fabrication shops did not possess, because most fabrication shops had not been run for 12 years before opening by a former aerospace structural engineer. The notebook was on the shelf above the main workbench. Not displayed. Placed the way you placed something that was a working document rather than a memento. It was the same notebook Tom had used for 12 years at Meridian Aerospace in Michigan, a large format engineering notebook. Hard-covered, filled from front to back with constraint solution sketches and first principles engineering notes from 12 years of designing structural components for aircraft that had to work under conditions that left no margin for approximation. The first page had a note written in red pen, not Tom's handwriting. His supervisor on his first day at Meridian, a woman named Dr. Clara Ye, who had spent 30 years in aerospace structural engineering, and who had welcomed Tom to the team with one sentence written on the first page of the notebook she had handed him. It said, "The constraint is not the enemy. The constraint shows you where the real solution lives." Tom had read it thousands of times across 12 years. He had left Meridian 4 years ago when Mia's mother died. He had moved to Newark. He had opened the shop. He had put the notebook on the shelf above the workbench where he could see it every time he looked up from whatever he was working on. He picked it up that morning before driving to Commerce Drive. He put it in his jacket pocket. He did not know why yet. He usually didn't. Catherine Moss had built her company on access. Not expertise alone, access. The specific ability to reach the people, the facilities, and the resources that other operations could not reach, at the speed that clients whose vehicles cost millions of dollars and whose schedules did not accommodate waiting required. She had built Moss Prestige Automotive across 13 years into the most connected hypercar service operation in the country. Her network spanned 12 countries. She had relationships with manufacturer-certified technicians, independent specialists, and private engineering consultants whose names did not appear in public directories, but whose phone numbers she had memorized, because having them at 2 a.m. was the difference between a client whose problem was resolved and a client whose car sat broken in her facility for 3 weeks. She had spent the previous 48 hours calling every number she had. The fault in the Bugatti was specific, and the responses she had received were consistent. The secondary turbocharger mounting bracket on the W16 engine had developed a microfracture under sustained high-boost operation. The bracket had to be replaced. Replacing it required access to the mounting point, which sat at the center of the engine in a location that was only reachable by splitting the car at its central chassis joint, separating the front and rear monocoques at the point where they were bolted together during original assembly. This procedure required a specific hydraulic separation rig. The rig existed in 2 locations in the world: Bugatti's production facility in Molsheim, France, which had confirmed a 4-week minimum lead time for a non-emergency service intake, and a certified repair facility in Stuttgart, Germany, which was currently committed to 2 existing projects and could not take the car for 6 weeks. Every other specialist Catherine had contacted had delivered the same verdict. Without the proprietary rig, the chassis could not be separated safely. Without separating the chassis, the bracket could not be reached. Without reaching the bracket, the car could not be fixed. She had offered $200,000 to whoever could prove otherwise. 300 mechanics across 12 countries were currently in transit or had confirmed they were coming. The first wave was boarding in Frankfurt, the second in Tokyo. A third group had left Los Angeles the previous evening. Every one of them believed they would find a way. Every one of them, Catherine suspected based on the conversations she had been having for 48 hours, would arrive at the same conclusion as the people who had already looked that the rig was not a convenience, but a requirement, and that requirements without substitutes were walls, and that walls in this specific situation meant a $4. 2 million car sitting in her bay when the most important showcase event of her year started in 14 hours. She was on the phone with the Stuttgart facility, attempting one more negotiation, when Tom walked past the bay window. She did not see him. Her operations director, a man named Carl who had been with her for 7 years, and who had learned across those 7 years to notice things Catherine was too occupied to notice, saw Tom stop outside the bay. Carl saw Tom look at the diagnostic report on the wall screen. Carl saw Tom read it. Carl had been in this industry long enough to recognize the difference between a person reading a technical document and a person understanding a technical document. Tom was doing the second thing. Carl said nothing. He waited. Tom had already walked toward the bay entrance before Carl had decided what to do about what he was observing. Catherine had ended the phone call. She had looked at Tom for approximately 3 seconds, the clipboard, the fabrication company logo on his jacket, the notebook he had pulled from his pocket and opened to a blank page, and she had made the calculation that a person makes when they have exhausted every option that their professional judgment would normally endorse, and are now in the territory of options that their professional judgment would not normally consider. She had said, "Prove it." She had said it as a decision, not a question. Tom had nodded. He had walked to the bay, to the workbench along the left wall, and he had put the notebook flat on the bench and looked at the diagnostic report on the screen for 90 seconds without writing anything. Carl stood at the bay entrance. Catherine stood behind Carl. Her lead technician, a man named Ross, who had 17 years of hypercar service experience and who had spent the previous day on the phone with the Stuttgart facility himself, stood near the car and watched Tom the way you watch someone who had said something improbable and whose next action would determine whether improbable meant impossible or merely unexpected. Tom began to write. Not the fault, not the specification, the constraint. He wrote, proprietary rig function separate front and rear monocoques at chassis join. Apply controlled, even hydraulic pressure at 4 points simultaneously. Maintain alignment within 0.2 mm during separation to prevent stress on carbon fiber join surfaces. He underlined, controlled even, simultaneous, wind 2 mm. He looked at what he had written. He opened the notebook to a page from his Meridian years, a constraint solution sketch from 2016, for an aircraft wing spar separation jig he had designed when the standard tooling was unavailable and a maintenance window was closing. The principle was identical. Different materials, different scale. Same engineering problem. The constraint is not the enemy. The constraint shows you where the real solution lives. He began sketching. Steel plate based the press in his shop could cut it to spec in 8 minutes. 4 hydraulic jack positions. His shop had 4 matching hydraulic jacks, with the load capacity required. Alignment guides machined from aluminum bar stock, the CNC mill, could produce them in 12 minutes if he simplified the geometry correctly. The whole assembly could be positioned under the car's chassis join, using the rolling floor jack his shop used for heavy component work. It was not the proprietary rig. It was what the proprietary rig did, built from components that existed in a fabrication shop in Newark. Tom looked at the sketch for 60 seconds. He checked the load calculations on a second page. The carbon fibre monocoque separation point specifications were in the diagnostic documentation on the screen. He read them. He adjusted 2 numbers on the sketch. He looked at Ross. Tom, does your shop have a CNC mill? Ross, yes. Tom, hydraulic floor jacks 4 matching units. Minimum 3-ton capacity each? Ross, yes. Tom, aluminum bar stock, 40 millimeter diameter? Ross, I'll check. He checked. They had it. Tom tore the sketch page from the notebook and handed it to Ross. Tom, cut these components. In this sequence, the steel base first, then the alignment guides. I'll supervise the mill work. Ross looked at the sketch. He looked at Catherine. Catherine looked at the sketch. She looked at the specifications on the diagnostic screen. She looked at Tom. She said nothing for a moment. Then, Ross, do what he says. Ross went to the mill. Tom followed. Carl looked at Catherine. Catherine looked at the clock on the wall. 13 hours and 22 minutes. Subscribe right now. Because what happens at that mill in the next 40 minutes is the reason 300 mechanics were unnecessary. Hit that button. New story every week. The fabrication took 37 minutes. Tom ran the CNC mill himself, not because Ross was incapable, but because the tolerances on the alignment guides required the specific adjustments that only the person who had designed them understood well enough to make correctly in real time. He stood at the machine and watched the aluminum bar stock become the guide components from his sketch, with the focused patience of someone who had done this kind of work under pressure before, and who understood that patience and speed were not opposites, when the work required precision. Ross cut the steel base plate on the plasma cutter. Accurate, fast, the 4 hydraulic jacks were positioned and measured. Tom assembled the components on the bay floor beside the Bugatti in 11 minutes. The result did not look like the Bugatti proprietary separation rig. It did not need to look like it. It needed to do what it did: apply controlled, even hydraulic pressure at 4 points simultaneously, while maintaining chassis joint alignment within 0.2 millimeters. Tom checked each positioning point against the chassis joint specifications. He adjusted 2 jack positions by fractional increments. He checked again. He looked at Catherine. "Tom, I need everyone out of the immediate bay area except Ross and 1 other technician. The carbon fiber separation generates micro-stress fractures if anything impacts the joint surface during the process. People moving in the bay creates floor vibration." Catherine cleared the bay in 40 seconds. She stood at the bay window with Carl. Ross and a technician named Pete positioned themselves at the jack controls, 2 jacks each, coordinated release on Tom's count. Tom placed both palms flat on the chassis joint surface above the separation point. He held them there for 15 seconds. Ross looked at Pete. Pete looked at Tom. Tom said, "On 3. Even pressure. Match each other's pace exactly. 1 millimeter per count." Ross said, "Ready." Tom, 1. The jacks engaged. Tom, 2. The chassis joint surface moved under his palms, the specific micro-vibration of carbon fiber composite beginning to release from its bonded position. A sensation that Tom recognized not from automotive work, but from 12 years of aircraft composite separation procedures that operated on identical principles, because physics did not change its rules based on what the composite had been used to. Build. Tom, 3. The chassis separated, not dramatically, not with a sound that communicated failure or stress or the wrong kind of force being applied, with the clean, deliberate movement of a correctly engineered procedure being executed at the correct pace by people who understood what they were doing and why. The front and rear monocoques of Catherine Moss's Bugatti Chiron Supersport separated at the chassis joint in the specific clean alignment that the proprietary rig at Bugatti's factory in Molsheim produced. Tom checked the joint edges with the alignment gauge he had brought from his shop. 0,017 millimeters. Within specification. He stood up. Ross was looking at the separated chassis. He looked at the improvised rig on the floor steel plate. 4 hydraulic jacks. Aluminum alignment guides machined in a fabrication shop in Newark. He looked at Tom. "Ross, how did you know that would work?" "Tom, the rig solves a structural separation problem. Structural separation problems have physical requirements: controlled force, even distribution, alignment maintenance. Those requirements can be met by different tools as long as the tools meet the physical specifications. I designed tools that met the specifications. Ross, from scratch. In 40 minutes. Tom, the sketch took 22 minutes. The fabrication took 37. We've been in this bay for 59 minutes total." Ross looked at the chassis again. He looked at Pete. Pete looked at the chassis and said nothing for a moment. Then Pete said something that was not a technical observation, and that was accurate. With the chassis open, the bracket replacement was standard work. The secondary turbocharger mounting bracket was accessible, visible, and removable, with tools that existed in every serious automotive workshop in the world. Tom stepped back and let Ross lead the replacement. This was Ross's expertise. The specific hands-on familiarity with Bugatti's W16 engine architecture that Tom did not have, and did not need to pretend to have. The bracket came out in 14 minutes. The replacement unit, sourced by Carl from Catherine's parts, inventory the moment the chassis had separated, and the access point was confirmed, went in 18 minutes. Tom supervised the chassis reassembly. The process was the reverse of the separation controlled. Even hydraulic pressure in the closing direction. Alignment guides maintaining position. Tom's palms on the join surface reading the compression the same way they had read the separation. The chassis closed. Tom checked the join alignment. 0,014 millimeters. He removed the improvised rig from the floor. He looked at Ross. Tom torqued the join fasteners to the factory specification. Full sequence, not partial. Ross. Yes. Tom. In order. Don't skip any position to save time. Ross. Understood. Tom picked up his notebook from the workbench. He walked to the bay entrance. Catherine was at the window. She had been at the window since the chassis separated, not moving, not making calls, watching with the specific, complete attention of a person who has given a situation over to someone else and is managing the specific difficulty of that surrender. Tom, Ross can finish from here. The bracket is replaced and the join is correct. He'll need 40 minutes for the fastener sequence and then a full systems check before you start it. Catherine, that's 40 minutes I have. Tom, you have more than that. She looked at him. Tom, the first wave of mechanics lands at JFK in 2 hours and 11 minutes. You have the car back before any of them clear customs. She was quiet for a moment. Then she went to Carl. Catherine, call the Frankfurt coordinator. Tell them the problem is resolved and we won't need the team. Carl, all of them? Catherine, all 12 countries. Thank them for coming. Cover any non-refundable costs. But yes, all of them. Carl made the calls. Catherine came back to Tom. She said, the Frankfurt coordinator asked what specialist we used. Tom, what did you say? Catherine, I said a fabrication engineer from Newark. Tom, what did he say? Catherine, he asked if that was a company name. A pause. Tom, what did you tell him? Catherine, I told him it was a person. She looked at him for a moment with the expression of someone who has just spent 48 hours in a situation and has arrived, without planning to, at the resolution of it through the most unexpected available route. Catherine, I need to ask you something. Tom, yes. Catherine, the notebook. You had it in your pocket when you walked in. Tom, I usually carry it. Catherine, you designed the rig in 22 minutes because of what's in that notebook. Tom, because of what 12 years of using that notebook taught me about how to think about constrained problems. The notebook is the record. The thinking is the tool. Catherine, what were you doing for 12 years? Tom, aerospace structural engineering, aircraft component design. 12 years of designing solutions to problems where the standard tooling wasn't available and the maintenance window didn't wait. Catherine, you applied aerospace engineering to a Bugatti chassis separation. Tom, I applied first principles structural mechanics to a separation problem. The material was carbon fiber composite. Aircraft used carbon fiber composite. The physics was the same. Catherine, and you knew that standing at the bay window reading the diagnostic report. Tom, I recognized the constraint. Once you recognize the constraint, the solution space opens up. She looked at the bay where Ross and Pete were working through the fastener sequence with the methodical attention of people who understood they were finishing something important. The deep blue carbon Bugatti Chiron Supersport was being put back together. By the time the Frankfurt mechanics landed at JFK, it would be running. Catherine looked at Tom. Catherine, I'd like to talk to you about something. When Ross is finished. Tom, I have time. The car started at 4:17 in the afternoon. The W16 fired, with the specific complete authority of an engine that had been correctly reassembled all 16 cylinders, all 4 turbochargers, the secondary mounting bracket in its correct position and correctly torqued, the chassis joined sealed and fastened to factory specification. Ross stood beside the car and listened to it idle. He had been in hypercar service for 17 years. He had heard a Bugatti W16 start hundreds of times. This one sounded different to him, not in its mechanical character, which was identical to every other Chiron he had worked on, in what it represented. A car that had been officially unfixable by anyone outside of 2 facilities in the world had been fixed in a fabrication shop in Newark, using a rig designed in 22 minutes by a man who had never worked on a Bugatti. He looked at Tom. He did not say anything. He did not need to. Catherine's office was on the 2nd floor. Not the glass-fronted client office, the working one. The room where the actual decisions happened, with the whiteboard that still had the 48-hour timeline on it, and the printed flight manifests from 12 countries spread across the left side of the desk. She poured 2 coffees. She sat across from Tom. She said, "Tell me about the aerospace work," he told her. 12 years. The structural component design, the specific expertise and constraint engineering, the discipline of finding solutions when the standard tools, standard materials, and standard procedures were unavailable, and the timeline was fixed. The kind of engineering that aircraft maintenance required on a daily basis, because aircraft operated in environments where standard conditions were a theoretical baseline rather than a reliable reality. Catherine, and you left because of Mia. Tom, my wife died 4 years ago. Mia was 5. I was in Michigan. I moved back to Newark where I had family. I opened the shop because it was the work I could do in Newark with the equipment I could afford. Catherine, and the aerospace clients? Tom, I have 2 retainer relationships with aerospace maintenance firms that use me for remote constraint analysis. It covers what the shop doesn't cover. Between the 2, I manage. She looked at the flight manifests on the desk. Catherine, 300 people, 12 countries, $200,000 offered. Tom, yes. Catherine, every one of them gave you the same answer before they arrived. Tom, they gave you the right answer based on how they understood the problem. The proprietary rig is the correct tool. What they didn't ask was whether the rig's function could be reproduced by different means. They assumed the tool was the requirement rather than the function being the requirement. Catherine, because nobody had asked that question before. Tom, because nobody with the background to recognize it as a legitimate question had looked at it. She was quiet for a moment. Catherine, I want to offer you a technical consultancy role. Constraint engineering applied specifically to the situations this facility encounters, where standard tooling and standard procedures are unavailable, and the solution needs to be invented rather than applied. You work here on the problems that our team can't solve through conventional means. Your aerospace background, your fabrication capability, your first principles approach applied to the hypercar world. Tom, I keep the shop. Catherine, yes. Tom, my hours have to accommodate Mia. I leave at 3:15 every day. Catherine, 3:15 every day. Tom, without exception. Catherine, without exception. Tom, and I have one condition. Catherine, tell me. Tom, 2 apprentice positions. Young engineers from Newark. Real constraint engineering training, not observation. Real problems, real solutions, real accountability. I teach them what I was taught. 2 per year. Catherine, why 2? Tom looked at the notebook on the desk between them. Tom, Dr. Clara Ye took 2 junior engineers every year for 30 years at Meridian. She said the knowledge was only worth keeping if it kept moving. I have been the next person the knowledge moved to for 12 years. These 2 positions are the next movement. Catherine looked at the notebook. Catherine, she wrote the note on the first page. Tom, on my first day. Catherine, the constraint is not the enemy. Tom, the constraint shows you where the real solution lives. She extended her hand. He shook it once. He picked up Mia at 3:15. She performed the 3-second face assessment before her seatbelt was on. Mia, good day. Tom, very good day. Mia, the Bugatti place? Tom, yes. Mia, was there a Bugatti? Tom, yes. She wrote something immediately. Mia, did you fix it? Tom, yes. Mia, how? He told her on the drive home. The constraint, the proprietary rig, the 22 minutes, the sketch, the mill, the chassis separating, the mechanics landing at JFK while the car was already running. She listened with the complete attention she brought to things that contained everything interesting about a day compressed into a story. When he finished, she was quiet for a moment. Then, did you use the notebook? Tom, yes. Mia, Dr. Ye's note? Tom, the principal, yes. She thought about this. Mia, can I see it tonight? He said yes. After dinner, after homework, Mia sat at the kitchen table with the notebook open to the first page. She read the red pen note. The constraint is not the enemy. The constraint shows you where the real solution lives. She read it twice. She looked up at Tom. Mia, is this why you fixed it when 300 people couldn't? Tom, they couldn't because they saw the missing rig as a wall. I saw it as a direction. Mia, a direction to where? Tom, to the question behind the wall. What does the rig do? If you answer that question, the wall stops being a wall. She was quiet for a moment. Mia, Dr. Ye taught you that. Tom, on my first day. Mia, and now you'll teach it to 2 people a year. Tom, starting next month. She picked up her pen. She wrote in her own notebook. She showed it to him. It said, the wall shows you the question. The question shows you the door. Grandma Ye found the door first. Dad walked through it today. Now 2 people a year will learn where to look. He read it. He looked at her. Tom, when did you get so precise? Mia, I learned it from someone who learned it from someone. He closed the notebook. He turned off the kitchen light. They went upstairs, and somewhere across the city, at a facility on Commerce Drive, a deep blue carbon Bugatti Chiron Supersport sat in its bay running correctly fixed by a man who had never worked on a Bugatti, using a rig that had never existed before that morning, because a woman named Dr. Clara Ye had written one sentence in red pen on the first page of a notebook 30 years ago. The constraint is not the enemy. The constraint shows you where the real solution lives. It always had. It always would. Tom Reed's first 2 apprentices started at Moss Prestige Automotive 6 weeks later. The first thing he taught them was not automotive systems or fabrication techniques. It was how to read a constraint, how to look at a wall and ask what function the wall was performing, and whether that function could be performed differently. On their 3rd week, one of them designed a solution to a tooling problem that had delayed a client job for 4 days. She solved it in 35 minutes. She had learned where to look. Subscribe now and share this with one person. New story every single week.